Could AI be the catalyst that revolutionizes the energy sector as we know it? In a world that is increasingly reliant on energy, the current state of the energy sector is a mixed bag. On one hand, we've made tremendous strides in developing cleaner, more sustainable energy sources. But on the other, we're still grappling with the complexities of managing and optimizing these resources. This is where artificial intelligence, or AI, comes into play. Let's take a moment to understand why this is a challenge. The energy sector is a vast, intricate network that requires meticulous planning and management. It's not just about generating power. It's about predicting demand, optimizing supply, ensuring reliability, and integrating new sources of energy into the grid. And all these tasks are becoming increasingly complex as we transition towards more sustainable sources of energy. So, how could AI help? Well, at its core, AI is about using machines to replicate human intelligence. This means machines can learn from experience, adjust to new inputs, and perform human-like tasks. In the context of the energy sector, this could translate into more accurate energy forecasting, more efficient grid optimization, and smoother integration of renewable energy sources. For instance, imagine a system that can accurately predict energy demand based on a multitude of factors like weather patterns, historical consumption data, and time of day. Or a grid that can automatically adjust to changes in supply and demand, minimizing waste and maximizing efficiency. Or even a renewable energy source that can seamlessly integrate into the grid, overcoming the traditional challenges of variability and intermittency. These aren't just theoretical possibilities, they're real, tangible improvements that AI can bring to the energy sector. And the implications are profound, from reducing our carbon footprint to improving energy security and affordability. As we delve deeper into this topic, let's take a look at some real-world examples where AI has already made a significant impact. Think about energy forecasting, a critical aspect of the energy sector. AI is already making strides here. Picture this. You're a wind energy producer and you have a problem. The wind, as it turns out, is unpredictably fickle. It doesn't always blow when you want it to, and sometimes it blows too much. This unpredictability can lead to wasted potential or an inability to meet demand. Enter Google's DeepMind. In a bold move, Google trained its AI to predict wind power output 36 hours in advance. The result? A dramatic improvement in the value of wind energy by 20%. Now that's what I call a game changer. But that's not all. Across the globe, AI is being used to predict solar power generation based on weather patterns and historical data. This means solar power plants can optimize their operations, reducing waste and increasing efficiency. Then there's the case of AI predicting energy demand. By analyzing data from a multitude of sources such as weather forecasts, historical consumption data, and even social media trends, AI can provide incredibly accurate predictions of future energy consumption. This allows energy providers to better manage their resources, reducing costs and improving service. Now, let's pause and take that in. AI, with its ability to analyze vast amounts of data and make accurate predictions, is revolutionizing energy forecasting. Just imagine the implications of such accurate forecasting on our energy consumption and sustainability goals. Now, what about grid optimization? Can AI help us there? Absolutely. AI is transforming the way we manage and distribute energy through the grid. It's like having a super smart, invisible hand ensuring that energy flows efficiently, reducing waste and saving costs. Let's take a look at a real-world example. Siemens, the German industrial giant, has developed a self-optimizing grid system powered by AI. The system uses an array of sensors and smart meters placed throughout the grid. These devices collect a wealth of data, everything from energy usage patterns of households to weather conditions that might affect energy production and distribution. This data is then analyzed by AI algorithms that can make predictions and decisions in real time. The AI can predict when and where energy demand will peak and adjust the distribution accordingly. It can also detect anomalies that might indicate a potential fault or failure in the grid. In such cases, it can reroute energy to avoid blackouts and even dispatch maintenance crews to the affected area. The result? A smarter, more efficient, and more reliable power grid. Energy waste is reduced, costs are lowered, and the risk of blackouts is minimized. But it's not just about efficiency. AI and grid optimization also enhances the resilience of our power systems. It enables us to better handle unexpected events, such as extreme weather conditions or sudden surges in demand. This is not just about efficiency, but also about reliability and resilience in our power systems. And what about renewable energy? Can AI help us integrate these sources more effectively? The answer is a resounding yes. Renewable energy sources like wind and solar are inherently unpredictable. They depend on weather conditions, which can fluctuate rapidly, making it tough to plan their use in our energy grids. That's where AI comes into play. Artificial intelligence, with its ability to analyze vast amounts of data and predict patterns, can help us predict the output of renewable energy sources with remarkable accuracy. For instance, consider IBM's hybrid renewable energy forecasting technology. It combines weather prediction and AI to forecast the availability of wind power and solar energy. This information is essential for grid operators who need to balance supply and demand, but AI's role in renewable energy integration doesn't stop there. By learning from historical data, AI can also help design more efficient renewable energy systems. It can optimize the placement of wind turbines or solar panels to maximize their output, taking into account local weather patterns and geographical features. Further, AI can help in managing the distribution of renewable energy. It can dynamically adjust the energy mix, shifting between different sources based on their availability and demand. This ensures a smooth, uninterrupted supply of power, even when the sun isn't shining or the wind isn't blowing. With such advancements, a future where renewable energy is the norm, rather than the exception, seems within reach. So what have we learned today about AI and the energy sector? We've seen that artificial intelligence is not just a buzzword, but a powerful tool that's transforming the way we generate, distribute, and consume energy. It's reshaping energy forecasting, providing accurate predictions that help us better manage resources and plan for the future. AI is also revolutionizing grid optimization, making our energy systems more efficient and reliable. It's minimizing power wastage, reducing operational costs, and ensuring a steady supply of energy even during peak hours. And let's not forget the role of AI in integrating renewable energy into our grids. It's helping us harness the power of the sun, wind, and water more effectively, and making renewable energy a viable, sustainable option for the future. As we continue to explore and innovate, there's no telling what the future holds for AI and energy. But one thing is certain, it's a future worth watching.